Hello again. In this video, you're going to learn how to make metallic hydrides, or hidruros metálicos in Spanish, which are binary compounds with hydrogen and any metallic element from the periodic table. Remember the diagram of electronegativity? If you combine hydrogen with any metal, hydrogen will always be stronger because all metallic elements are to the left of the hydrogen in this diagram. This means that hydrogen will always take electrons using his negative oxidation number of -1, and metals will always give electrons to hydrogen. You also know from this diagram that in the formula you get, you should write hydrogen in the last place always, because it's stronger than any metal. Remember, the strongest atom is written the last in the formula. Let's see some examples. Let's combine, for example, hydrogen and sodium. We have said that hydrogen in the metallic hydrides is going to take one electron always, acting with its oxidation number of -1. As a result, hydrogen wants to take one single electron. And as sodium has an oxidation number of +1, it means that he wants to give one electron. And that's a perfect couple again. One given electron plus one accepted electron is equal to 0, and then we get the formula of the compound of sodium and hydrogen, which is NaH. This means again that when sodium and hydrogen combine, they combine in the same proportion, the same number of atoms of sodium and hydrogen. And notice that we have written hydrogen in the last place because it's stronger than sodium. Let's now combine hydrogen with magnesium, for example. Hydrogen again is going to take one electron, acting with its oxidation number of -1. And as magnesium has an oxidation number of +2, it means that he wants to give 2 electrons. But then we need 2 hydrogens, 2 atoms of hydrogen to take those 2 electrons. So 2 given electrons plus 2 accepted electrons is equal to 0. And then we get the formula of magnesium and hydrogen, which is MgH2. That means that when hydrogen and magnesium combine, they don't do it in the same proportion. There are more atoms of hydrogen than magnesium, double the atoms of hydrogen than magnesium. In the last example, we want to make the compound of hydrogen and iron. As iron has 2 possible oxidation numbers, we can make 2 different compounds, one for each oxidation number. So we have 2 possible compounds for iron, one acting with +2 and one acting with +3. This means that this iron wants to give 2 electrons and this one wants to give 3 of them. So in this case, we need 2 atoms of hydrogen to take those 2 electrons. And in this other case, we need 3 atoms of hydrogen to take those 3 electrons. And so we get the formula of this compound, which is FeH2, which is one possible compound of hydrogen and iron, and the formula of this other compound, which is FeH3, the other possible compound of hydrogen and iron.